In this session, we will learn about the basics of R and RStudio. Therefore, the first step is obviously to understand a bit better what is actually the distinction between R and RStudio. Then we will look at the basic RStudio overview. I will give you some suggestions of how you could adjust the general settings. We will see what is relevant in the very first stage, and we will issue our first commands written in R to the computer, see how this works, and then look at the next topic, which will be more about more elaborated techniques of using R, like writing our own functions and calling different kinds of objects. The very first thing, and I guess it's often underestimated, is to understand like the general framework of how R and RStudio work together to help you solving statistical problems. Now, when it comes to R and RStudio, it's very important to stress that R as such is a programming language. So you can think of that as a language that, in the best case, both you and your computer understand. And that's a language that allows you to communicate certain tasks to your computer to solve them. So here's, for example, a function call in R. We will learn more about functions later on. This is basically a function called fibn with an argument 4. And it actually gives us, tells the computer to compute the fourth Fibonacci number. What is actually happening if you issue such a command in R to your computer is that your computer translates this language R into a language that actually the technique of your computer can immediately understand. That's a very so-called low-level language, which is basically unreadable by humans. So whereas R is a language that is, after a bit of training, readable by humans, this assembler code here is, it's also readable by humans, but you really need to invest a lot of time, and I don't recommend you to invest your time into it. But that's actually what's happening. So the R code is taken, and maybe there are a couple of intermediate steps, but in the very end, it's translated into something that the technical parts of your computer can immediately translate into certain actions and to complete certain computations. And this will then, in the end, lead to a result that is then, in the very end, recommunicated to you. So in this case, the function fibn4 allows us to compute the fourth Fibonacci number, and this number is actually 3. So this is what R does. R is a programming language that allows you to issue commands to your computer and to actually tell it to fulfill certain computations for you. Now, RStudio is a so-called integrated development environment. That's something different. This is how RStudio looks like in practice. And RStudio is a tool that facilitates the use of R. It's not a programming language in itself, but it's a tool that helps you to use a programming language, namely R. So you can think of it as basically as a fancy text editor with a lot of additional features that make programming easy. There's this nice analogy in this book where you say that R as a programming language is like the engine of a car, and RStudio is like the dashboard that actually allows you to control the engine and makes it much easier to use it in practice. That is also why you were required to install R first and only then to install RStudio, because it doesn't really make sense to have a car dashboard without an engine. And the same is true for RStudio and R as such. That also means that once you installed R and RStudio, while there is an app on your computer that is called R, you're basically never gonna use it directly. What you usually do in practice is you open RStudio and interact with R indirectly through RStudio because it's simply much more convenient to do so. And because of this, in the next step, we will have a closer look at how the RStudio interface actually looks like. Now, if you open RStudio for the first time, it should look a little bit like this. Of course, on your computer, and depending on your OS, it might look a little bit differently, but in general, this is how it looks like. Now, the first thing to do is to change some of the basic settings of RStudio. Well, this is not strictly required. I recommend you to do that right from the beginning because it just facilitates the common progress. So on a Mac, you go on Tools and then on Global Options. In Windows, it's slightly different, but you should also reach this option menu. And in general, there is this option here, Save Workspace to .r data on exit. It is very likely that the default option for you is here an always or an ask. And I recommend you to choose never and to apply these settings. That actually helps you to avoid writing like big intermediate data on your computer that actually slows down the whole process. Also, depends a little bit on your preferences, but here in the appearance part, you can actually choose a different look of RStudio. Many people, for example, prefer a dark background, so then it looks like this. For the reasons for the sake of the video, I'll choose the brighter background because that's easier to read for you. But here in the appearance, you can actually choose an editor theme you like. You can also download some additional themes from the internet and use them. Or you can, of course, change things here like the editor font size, etc. So I recommend you to take a couple of minutes and here adjust the whole thing to your needs, and maybe just also look a little bit at the other parts here of the options and to choose things you like. One thing I also recommend you to actually activate is when you click on Code and then on Display, to have the margin column at 80 characters, which actually allows you to write better scripts that are more easy to read. And I also recommend you to tick this option, use rainbow parentheses, which facilitates actually the use of parentheses in practice because they are marked by different colors depending on which level they are. Aside from that, I really recommend you to go through these options, especially the appearance options, and to choose like the options you like most. It's also a little bit of trial and error thing. Aside from that, let's focus actually on the functioning of RStudio. Now, this is how RStudio looks like when you start it. Most of the time when you're working with RStudio, you will have a script open. A script is basically a text file that contains our code. You can create a new script by clicking here on this button on the upper left on New File, and then click on our script. Then here the script editor opens, and this is actually how RStudio looks for you most of the time. Most of the time it's the case that here in the upper left part of the picture you have your current script or your current scripts open. And what is here, that is basically an elaborated text editor in which you can write text, or in which you most of the time also like write R commands. That you can then execute later on. The nice thing here about the scripts is that you can write stuff and save it for later use. If you click here on the Save button, you're actually asked where to save your script. And we will learn a bit more about where it's wise to save a script. But for now on, it's just relevant, just necessary for you to know that you can actually do that. Down here in the lower left level, we have a window with several different tabs. The standard tab that is opened is the so-called console. The console could be thought of as like a channel through which you can communicate with your computer via the use of R. So in the console, you can type R commands. And if these commands are written correctly, then the computer understands them and executes them. So it's a little bit similar to the terminal in your OS. So one kind of valid R code would be, for example, 2 + 2. If you write this R code and you press enter, then what is actually happening is that the computer translated into machine code executes this computation and returns back to you the result. So in this case, here the computer just computed 2 plus 2 and the result is 4. That is basically the idea of the console. And there is a strong relationship between the console down here and the script over here. Because the thing with the console is if you close RStudio or if you close R and you reopen RStudio, then everything down here will be lost. The console will be empty. But sometimes you develop R code that you want to keep. You want to save it. And to do that, you need a script. Now, here in the script, we have written the command 2 plus 3. If we mark this code and we click on the run button over here, what is actually happening is that this code gets executed down here in the console. That is basically the same as if we had copied the code here from the script, pasted it on the console and pressed enter. And you see here that exactly the same has happened. So the relationship between the script here and the console down here is that in the script you can write R code that you can then save on your computer, but that you can also immediately run, and this basically needs to push it from here to there and to execute it immediately. The most important button up here is, as I said, the run button. You can experiment with the others, but the run button is the one you will be using most frequently. Down here on the left, you also see two other tabs, Terminal and Background Jobs. If you click on Terminal, you're basically switching to the terminal of your OS. That is basically the same as if you opened on a Mac the app Terminal or the corresponding Windows app on a Windows computer. So here you can issue commands not in R, but in the language of your OS. We will not use that too much throughout this course. Similarly, the tab Backgrounds job is something that R is currently doing in the background, which is sometimes relevant, especially if you're using the exercises apps that I have prepared. But even then, it's not too relevant for you right now. I recommend you to stick here with the tab console most of the time. Now in the pane in the upper right, you see different tabs, the environment, history, connections, tutorial. The environment is basically an overview about things you have defined by your own in the current R session, but we will come to this later on. As with the console down here, I recommend to have the standard tab opened here, the environment. But as I said, we will learn a little bit more about that later on. Down here in the right, the standard tab that is open is Files. It basically shows you your current working directory. So that's the location in on your computer your current actions are executed at. Again, this is a concept that we will learn a bit more about later when we talk about how to set up our projects and work with them. What you do see here immediately is that the script I saved before shines up here, and I can open the script by clicking on this button here directly. So if I close it and I click on this, it automatically reopens the script. But again, the working directory we will dealing with at a later stage. The other tabs here similarly are giving you previews of the visualizations you did. They help you to design our packages. This is something we won't do here. They provide you with help if you ask R for help. And you get some other a viewer if you're working on a website, or a presentation if you're creating a presentation with R. That's not too relevant for us. The main tabs here will be Files, Plots, and Help. But again, this is something we are dealing with later on. We will now use RStudio to execute some of the basic computations and learn how we can actually issue commands to R. We actually already did this by typing something down here in the console and pressed enter. But we will do this a little bit more extensively now using the scripts here. When you write a script, the first important thing to notice is that usually everything that is written here gets interpreted as R code by the computer. However, if you write something after a hashtag, you're writing a so-called comment. And comment allows you to write text where you explain something to you and that does not get executed. So, for example, we could write here like basic computations in R. And if we run this line here, we see that actually nothing happens. R automatically skips to the next line and looks whether there is some valid R code there. But the line basic computations in R did not do anything. That is actually very useful if you want to write a script and you want to write down stuff and you want to write explanations to it. So, for instance, one thing we could do is we could think about the basic mathematical operations and how to implement them in R. So we start with addition. And we can now write an addition in R. We already learned how to do that. It's actually just using the plus sign. And if you add two numbers and you press the run button or the shortcut on your keyboard, which on the Mac is Command Enter, then you directly get the result. So this is how addition works. Now let's try out how we can effectuate the other basic techniques for mathematical techniques of computation here in R, which are basically subtraction, multiplication, division, and exponentiation. For all of them, R has its proper function, and there are symbols that actually facilitate the call of these functions. So for subtraction, you write you do not use the symbol plus, but you use the symbol minus. So if you write 10 minus 4 and we press enter, then we get the result 6 down there. If we want to multiply something, we use the star or the asterisk. If we want to divide something, we use the slash. And if we want to have the power of something, we actually use 2 asterisks in a row, and we get the result down here. There might be some things worth mentioning. First of all, when you make a computation down here, you see that you have the R code that you have written first, and then in the result line, you always see this 1 in squared brackets. That basically refers to the fact that in R, everything is a vector of length something. And every single number or every scalar is in R a vector of length 1. So 40 divided by 2 gives a single number, a scalar, 20, and R operationalizes this number as a vector of length 1. We will learn a bit more about vectors later on, but this is just for you to make sense of this 1 in square brackets. If you there's actually one way where you can create very long vectors in R, that is to use the double colon. And if you write 1 double colon 200, that basically creates a vector from the numbers 1 to 200. And this is just to give you to explain to you what this number in square brackets means. It means that the number that comes after it is the first element in the vector. Here we only had 1 entry, but after every line break here, the number at the beginning tells you which number this is. So 29 here is the 29th number in this whole vector, which contains the numbers from 1 to 200. So this here indicates that we get, as a result, a vector of length 1. Now, that's not terribly important for the moment, but I hope that makes sense for you. Similarly, this symbol here at the very beginning just is the standard symbol that R uses to mark a line in the console. You see that this symbol doesn't shine up here in the R script, so that shouldn't confuse you at all. Now, you actually learned one pretty important thing, namely how R works, in the sense that you can write R code here in a script, that you can save the script to your computer, that you can reopen it and thereby reuse everything that you have written in this script, and that executing the script can be thought of as copying something from up here in the script pasting it in the console and pressing enter, and that the console is basically your direct channel to interact with the computer by using R. This is an essential key message at the very beginning, and it's underlying many of the more complex techniques that we're about to use, that we're about to learn in the next step.